All right, day 2, VMware Explore Barcelona, and man, the general session just finished. Lots of announcements there, and I'm pretty excited. John, how you feeling?
I'm good, but I was trying to log into my lab on something, and I'm like, man, this is taking a lot to upload. I was trying to pull some files from it to get something ready, and I was like, I need to upgrade the network in my lab, I think.
Yeah, you should upgrade the network in your lab. I love John because his segues are always so right on time. We're actually going to be talking about we're going to be talking about a few things. We're going to be talking about GPUs, DPUs, and who better to have a conversation about DPUs than our good friend Dave Morera. Dave, welcome back to the podcast.
Thanks, Pete. John.
And joining us from NVIDIA is Motti Beck. Motti, welcome.
Thank you. Thank you.
So, gentlemen, I understand you had a session today, and the title of the session for those that are here is DPUs, your VMware Cloud Foundation secret weapon for scale and security. Let's start with that, and then we'll dive a little deeper into some of the meat and potatoes of the thing. But tell me a little bit about the high level. What was your session about?
Yeah, I mean, we talked about DPUs before several times, right? And to recap on that is what we're trying to do here with VMware and NVIDIA is leveraging these really cool devices, DPUs, which are essentially smart NICs, really cool NICs with, very fast, but also they have an ARM CPU, an accelerator, memory, storage. So we're installing the SXI on those devices, and by doing so, it's allowing us to install other agents on them, like NSX agents, and we can offload the services to the DPUs and not only speed up the process and power or the decisions that need to be made as to where these packets need to go, right? Packets come into the NIC and we're making all decisions there instead of having to go up all the way to the x86, right? So we're making these decisions a lot faster, so it's decreasing latency for a lot of customers.
So ultra low latency applications are leveraging that capability.
Yep.
You talk about the speeding up, but also let's talk about the offload. What does that look like in terms of, if I'm pushing lots of tiny packets, let's say UDP, things that historically firewalls, there's a lot of CPU overhead for. Like, what does it look like? How much am I saving, I guess, in that? Like, not just performance, but where's the offload of the CPU usage?
I'll give you the regular answer, right? It depends what the workload that you're using. Of course, the more network that you utilize, and the more you're going to see the benefit of it, because then we're decreasing a lot more. But when it comes to firewall rules, like you're saying, we're decreasing. We don't have to go up to the x86 CPU. So all that processing is going to be done at the DPU level, right? And then Motti, you can probably add to that. You know all the numbers as far as performance goes.
Actually, I would differentiate it between the different classes of acceleration that we're doing. One of them is offloading. Offloading means that instead of just running on the x86, we are going to run it on the ARM cores within the DPU. The DPU, specifically Bluefield 3, has about 16 cores of A78. And it's not just the controller itself, it's really what exists on the board. The board exists, the controller, the board has 32 gig of memory, it has a ton of storage. So in a way, it's a server. And the new architecture that we developed together with VMware is enabling server within a server. So you have the x86 to run the applications themselves. You have the GPU to accelerate the GPU, Gen AA stuff. And you have what I call the DPU, I would call it even a service processing unit to take all the overhead like security and networking and other
encryption
stuff.
And things like that.
So when you are doing those services, you can offload, running it on the A78, as we mentioned before, but there are also acceleration engine, mean any stateless operation like IPsec, it's a stateless operation, You can do it in a state machine, do it in silicon, you can accelerate it, and it's not just accelerating, doing it faster, but it also reducing the power because instead of running on a
general
CPU,
purpose CPU,
exactly, and so on.
This reminds me of mainframe architecture, like you talk about the service processors.
Exactly, there are those cycles. And the last one, it's not less important, maybe the most important, is the isolation. Today, when you are running the security, you are running it on the same x86 where the tenants are running. And now you are offloading it and running it on a different controller, so there are different control plane between what the tenants are running. And this we cannot measure specifically in performance. There are some benchmarks that we did that I can share later, but the most important is that it really enable a true zero trust deployment compared to what was before.
Oh, wow. So I can use that
is
to pixie boot and bring up the environment and have
exactly.
isolated security secrets.
So this is the main. We need to consider it as a new architecture for accelerated data center and not just a replacement of the NIC with another DPU. It's a totally different. So the new data center should include now 3 major processors, which is the CPU, the GPU, in case of you're running Gen AI, and the DPU. And this is the triangles that we are promoting.
And that's a great point, right? Like you said, now the servers should have this. So when a lot of customers are planning their server infrastructure reboot or purchases in the future, the next year or 2 years ahead, they should be thinking, hey, what is it that not just the NIC, but for a fractional cost, I can upgrade to a DPU. And maybe I can use it as a NIC only, or maybe I want to do offloading as well. So you have those choices, but they should be thinking ahead as to what is out there as far as technology, hardware innovations, and things like that. Because a lot of people are not really leveraging the hardware that they have.
When you look at the cost of a server, like where it's gone, historically, you go back many days ago, it's like, okay, I have X amount of RAM. These CPUs are a large part of the cost. Nowadays, I start putting GPUs in there that cost one Toyota Camry each. I'm putting in, $80,000 or 80,000, pounds worth of RAM. You start looking at some of these things, and anything I can do to lower the amount of hosts that I have to purchase that can get that more efficiency. Because if I'm bottlenecking on CPU and I have very expensive RAM or GPU that's sitting idle, like that's a problem.
Yeah.
So
I agree completely.
Balancing these resources.
But if you deep dive a little bit on about what is the GPU, everybody is talking about the application, which is the most important one. But in the essence is the GPU, practically, it's a parallel processing. It's a parallel processing. This is what makes it so fast. In a parallel processing, the networking must be the most efficient as you can be.
Any retransmits are going to cause
in a CPU,
problems
it's a sequential execution.
The memory bus or the PCI on the CPU.
Sequential information, if one of the phases is a little bit more, it takes more time. Then, so you have another 10%, the effect on the overall performance is really minimal. In parallel processing, think about it, there are a ton of operations running in parallel, and they are doing their best to finish the job. And if they need to wait for another one is delayed, then everybody is waiting. So they're very expensive.
It almost sounds like the network is my PCI backplane or my memory channel, like between the nodes. It's so important to make sure that
the job became so big that you cannot run it today on a one server. It's distributed system. Actually, I would argue today that the most critical job in a data center, in a Gen AI data center, is the communication. Because I talked to Dave before and I told him, you need to feed the beast. The GPU needs to get the information, and the scalability is so big that the network, unless it's the best, then you are going to, the efficiency is going to
we
be...
need non-blocking leaf spine backing this. You got to start looking at that.
So as we start to grow and we start to add more complexity to these environments, what does that look like for an infrastructure administrator that now is looking at managing servers, GPUs, DPUs? What does that look like from a lifecycle management perspective?
So that's actually one of the things that we've been working on a lot lately, and with VSphere 8.0 U3, we released not only the support for, we have support for dual DPUs. We announced support for Bluetooth 3, which is the newest from NVIDIA. But also, a lot of customers are asking, hey, now I have 2 DPUs per host. And essentially, I'm nesting because now I have 3 versions of ESXi. I don't want to manage 3 versions of ESXi as separate hosts. And I don't want to see, 3 times as many hosts in my vCenter. That would be crazy. I don't want that either. So some of the things that we did since the beginning was automating or making it super easy for customers to install ESXi. So when you're booting up, it's just a check mark. Pretty much that's the only change when you're booting up and installing ESXi. And we're leveraging VLCM, vSphere Lifecycle Management, to install all these updates on the DPUs, right? So we don't even ask you, do you want to upgrade or not? You want to upgrade the host, guess what? You get the update on the DPUs too. You want to install NSX on the host, guess what?
I don't have to check HCLs separately. It's just going to go deal with that.
So we're doing that automatically to make it easy. So you don't have to manage a DPU like a server. It is a server, like Motti said, but it's not. You don't have to manage it like a server.
But what we did together, actually, besides adding the new functionality from the end user point of view, from the IT manager, he will not see a difference between running vSphere with a DPU or without a DPU. It's not a different version. It's a feature within vSphere. It's called the vSphere Distributed Services Engine. And what you need to do actually is just to verify that the system knows that the DPU is there, and then to use it. User itself will not know any difference from the usability point of view, lifetime management. It's just another feature there, and it's the
very
same.
transparent. I feel like if I'm getting all this power, though, it should look different or something, or make a fun noise. Like maybe we can make those hosts a different color, like red. Be like, yeah, that's got the DPUs. Or something.
And there's a lot of work that goes into making it that it's easier too. Like we work a lot with NVIDIA on just making it seamless for customers, and that's not something that customers get to see. Right? They see the final product and they're like, oh, it's just a checkbox. Yeah, it's cool. But there's a lot that goes behind the scenes.
On this simplicity, like let's break this down to layer one. What does it look like to I put this DPU in there? What does this physically look like? How do I cable it? What are the connections?
Well, it's green.
Well,
it's a card, basically.
It's a card.
You are taking a server. It's like a NIC.
Yep.
Just it's a much bigger NIC.
Okay. Much more expensive NIC.
More expensive. But again, about the expensive, I want to emphasize again, it's not the DPU is not the next generation of a NIC.
Okay.
It's totally, it's totally enabled, totally
like
different architecture.
Kind of smells like a NIC. Looks a little big, but it has,
if you take a regular NIC, there is no memory, there is no compute, there is no storage. It's basically a peripheral that's controlled by the CPU. Here, it's by itself. It has its own, in a way, even operating system that you can run on top of it, not in the way.
So for the management of that, do I have a separate management breakout cable or physical cable,
yes,
or is it just through an in-band
So for older
PMC
versions
connection?
from the beginning, right, we had a separate cable.
I remember the little weird dongle.
Yes.
I'm like, where does this plug?
So we needed like a daughter card, but now with Bluefield 3, we're actually able to support just you plug and play pretty much on particular servers, which is going to help a lot of customers retrofit their servers.
Yeah, I always lose the little cables, so thank you. Like the big QSFP,
you don't need them anymore. Yeah, the feedback from customer was very loud and clear.
Yeah. Yeah, I remember talking to the server OEMs. They're like, we don't want to maintain like these in the parts bins.
And it makes it easier because customers don't want to have to wait a year or so until they can buy more servers to be able to have all these essential cables and cards. So now you can just buy a DPU from NVIDIA, plug it in, and then install ESXi.
So it sounds like these come in, you said speeds, they're 200 gig, 100?
100 and 200 on Bluefield 3, right? The Bluefield 2 is 25, right?
So I'll stack two of these in my host. So I've got 400 gigs of throughput there. Pretty great. So I'll need some 200 gig topper racks, break those out to 800 gig spines, and
for your
I'm ready to AI accelerate my way to the moon.
We'll be happy to provide this one as well, with our Spectrum switch, of course, no doubt. But we are joking about it, but it's serious. NVIDIA came with a Spectrum X technology or architecture that practically verified that you have the best networking possible. With the congestion control, avoid
ECN. I've always appreciated how simple it was to configure RDMA on Spectrum.
Yeah, it's RDMA, Rocky. We've been working with VMware for many years and enabling Rocky on the ConnectX family, but now it's already on the Bluefield. So this is.
It's fun with networking because you guys. I mean, I think virtualization people, we have too many acronyms. You guys are all about the three-letter acronyms: DCDX, ECN, TSCP.
It's not PFC, us. It's the high-tech industry. Unless you know the acronym, you don't exist.
That's exactly
the toughest one for me, for example, when I joined NVIDIA after the acquisition of Mellanox, is to understand the new acronyms that NVIDIA has been using.
Yeah.
So this is one of the most important.
It's a good marriage though, because you've got the GPU that's generating enormous amounts of networking traffic, and then the really fast networking gear. So I like it.
Excellent. Well, this has been fascinating. Motti, I want to thank you so much for joining us on Virtually Speaking. Dave, as always, best of luck with your session, gentlemen. And for those that are here, you can definitely download. This gentleman's been presenting all week in Vegas as well, and he's here. So there's been a lot of great sessions. Just look for Dave Morera on the content catalog, and you're going to find some great DPU goodness and some GPU goodness. And gentlemen, thank you so much for joining us.
Thank you, guys.
Thanks, John.
Thank you.
Thanks, Motti.